everyone again. We are very happy today to have Garrett Winther from HAX. So he's partner and program director at HAX Venture Capital. So for those of you who don't know HAX yet, this is a program-based venture capital for hardware startups. So they help early stage companies through their development and scaling phases at their location in San Francisco and Shenzhen. So Garrett is from Shenzhen. Today is with us to talk to us about how to go from prototype to mass production. And I know that is a topic very interesting for most of the startup from the ecosystem because we received many requests to learn more about this topic. So once again, welcome Garrett. Very happy to have you as a VIP guest today with us. I will let you the time you need to introduce the topic, share all the details to the attendees. And in the end, we'll have a Q&A session so that the participant can ask you all the questions about the topic. And the video will be available on YouTube afterwards if you want to watch it again. So thanks again, Garrett. And so I will let the stage is yours.
Great, thank you. Yeah, so today I just have a quick introduction, just a bit about HAX for just a couple of minutes, and then a very rapid fire intro to what it generally takes to go from prototype to production. So I would say we can't go through nearly everything in a short amount of time. So really the objective is to share some of the things to think about, some maybe quick tips and tricks, and ultimately set you down a path for the questions you should be asking, the things you should be Googling, and ultimately kind of head you down a path to understand the scale and scope of what it takes to take an early stage prototype into production. So just a quick introduction about HAX itself. So we are a venture capital program that's focused on hardware. So things that are in the physical world, things that need to be manufactured. And that ranges from IoT, robotics, health tech and medical tech, consumer electronics, really anything that has some sort of physical presence out in the world. That's what we're investing in. And we've done that for over 200 startups in the last 8 years. So again, focusing on teams from all over the world that are working on these really exciting integrated hardware businesses and starting to build and scale their businesses to some really exciting companies, some that are kind of reaching going public, many that have acquired, and ultimately kind of building up high value businesses across many different industries. And we really take, as I talked about, venture capital, but we do a very hands-on investment. So our goal is actually to invest, but then bring you into these ecosystems like in San Francisco, like in Shenzhen, and our newest office in Tokyo to really help towards commercialization of this tends to be difficult process of commercialization and bringing things to life, as well as scaling up your venture business, getting onto your next rounds of funding, and starting to build out your business at a broader scale as well. How that typically happens is that we write checks between kind of $175,000 all the way up to $2 million, bring teams into our program, and then from there do that for about 40 teams a year, and then ultimately we're actually backed up by a much larger venture capital group that wants to continue to see teams scale and grow into the future. And really, I think one of the key elements of that is where we're located. I'm sure the video isn't showing up very well over the internet, but if you haven't been to Shenzhen yet, essentially this is the center point for electronics and manufacturing of the world. And really, this is a picture of an area called Washington Bay where we have our office. And essentially, it's what you see on screen for over 2 square kilometers times 6 floors. Really, any piece that you want. Really, the central market for all of the manufacturing that happens in and around Shenzhen. And that's why we put our office here. So we have a 4,000 square meter office in Shenzhen where we have actively between 15 and 20 startups building out their projects, building out their production lines, and doing so kind of from a hub here in South China. And like I said before, kind of doing that over the last 8 years, focused on a range of different topics. Very early on, we were very heavy on consumer electronics, but actually as of late, a lot more focused on B2B, both enterprise and industrial, robotics, IoT, especially kind of thinking a lot of focus on connectivity, IoT, especially as larger companies start to industrialize, a lot of opportunity opening up with new products and services. And we do that for all over the world. So I know there's some listeners on from Europe, some from the States, some from all over parts of the world. And really we don't have any specific focus on where we invest, just looking for great teams working on really exciting problems. And just to give you kind of a scale of what we're investing in, this is an example of what a team would apply to us with. So this is a robotics team from North China. And you can see this is probably actually very similar to some of the prototypes that you guys are working on, where you have assembled all the technology, put it all together, but there's still kind of a big step to turning this into a product, into a service, into a larger scale business. So we invested in this team. We brought them to Shenzhen, and over the course of 3 months, they're able to go and actually launch a fully running autonomous pilot of this commercial vehicle inspection robot. So it goes around bus depots in Shenzhen, checking tires, checking the overall health of vehicles, and ultimately building a robotic service business around commercial vehicles. So doing that all in this rapid pace, rapid iteration, and doing so in one of the fastest moving economies in the world, and doing so with the infrastructure of Shenzhen. So that's my very quick intro on HAX. And just in general, we're really excited to work in this space, work with really amazing teams, and we are actually continuing on and actually investing more and more every single year in finding more and more success in working with teams from all over the world. So with that, that's kind of the context of HAX, a little bit where I come from. I'm gonna switch into a little bit about talking about prototype to production. And really the big thing here is that this is only about 25, 30 minutes, so there's only so much that we can go over. And the key is that it's not this kind of magical black box where you say, I want to make a whole bunch of something, and outcomes, your manufacturer makes them all perfectly for you for the first time. Actually, when you're going through this process, the first time, it actually feels more like this, where you're kind of spinning in circles, you're learning new information, you're kind of figuring out things the first time, you hit a huge roadblock, you don't know where you're going. Unfortunately, it also feels like that probably the second time as well. Like this isn't something that kind of just can be learned, but it's more something that requires you to dive into, understand the basics, but then also start just learning about all the different parameters that can both make your products better, your design better, and your business better at the same time. So we're gonna the rest of this is like I'm really just gonna go through a lot of slides really quickly, and I think hope of you guys being able to go flip back through that later on through YouTube, Google the things you need to Google, but ultimately get out there and just start making things, trying things, prototyping things, talking to potential manufacturers, and figuring out what it takes to actually bring something to market. So just a couple of frameworks just to kind of set a little bit of context. You can literally Google like production milestones and processes, and you'll see something very similar to this. So you'll kind of input with prototypes, and then you'll hear EVT, DVT, PVT, and MP. And those stand for engineering validation test, design validation test, production validation test, and mass production. And really what this is a set of milestones that slowly help you scale and validate what you're working on to make sure that when it goes into mass production or it goes into higher volume production, you're not going to end up with something that just doesn't work, right? A whole bunch of bricks that don't actually serve what your customers need. And so this is kind of industry standard acronyms and overall terms that ultimately kind of start speaking to, is this engineering ready? Is the overall design ready? Is this production ready? And then let's actually make a whole bunch of these things. So the way that this is often laid out, it's very linear. It's very kind of one-to-one. At HAX, one of our biggest pushes is actually thinking about this as more of an iterative process, thinking about how are you very quickly making prototypes, testing things, learning new things, making your designs better, to ultimately kind of get tighter loops down to the point where you can actually make 1,000 of something or 10,000 of something or 100,000 of something by quickly learning, not by kind of going and just learning everything by the book, but actually making prototypes. So each one of these loops that we talk about, just really simple loop of like making a quick plan, doing some design, so actually designing for manufacturer, designing for assembly, designing for your customer, making a quick prototype of that, or prototyping it in a certain way, and then going and testing it, whether it's testing it with customers, testing it with calipers and actually measuring it out, testing it with potential partners. So really kind of focusing on this entire process should be centered around how fast you can iterate, or how many times you can iterate in order to learn as much as you can through active prototyping. So I'll just make the assumption that everybody in the call, kind of with the preface of the talk, is coming in with some sort of prototype. Maybe you're in your garage, you're kind of soldering something together. Maybe you have a handful of prototypes that are out with customers, and really kind of it's an early stage where you've started to build out, hey, we have something, right? Congrats, you've got a prototype, it's working, people want it, it's time to make more. But in reality, like, this is like step one to a very, very long process. And really, there's a few really important things before you start thinking about getting mass manufacturing done, or actually working on making thousands of these things. You need to start asking a few really critical questions. So this is kind of going through that loop. This is kind of hitting on that first plan, right? Kind of that first step of actually going in and understanding what you're doing. And probably the most important thing before you make any more than a few of a prototype is, can you make a business out of this? Is this something that you can actually make and make money from? And is there sustainable and scalable business that can come from you making more than one of these things? And really the first question before you start any business is, do people actually want what you're making? And I would say the biggest error we see over and over again from early stage engineers, prototyping, first like prototypes overall, is that people don't actually want what you've built. And that's because you need to go talk to your customers. So if you haven't talked to a customer yet, or you talk to somebody who want to use your potential prototype, start there. So go find who you want to work with, who you're potentially actually building this for, and then start understanding the value proposition, the overall user experience, how you want to prioritize features. A lot of times companies will actually invest most of their time and energy in a feature that nobody actually wants. So actually having these conversations with their customer. And lastly, actually going out in context. So we actually have a few construction companies these days, and it's actually really important to go out to a construction site, see where things are happening, see where your product's going to live. Does it need to live in a very harsh environment? Does it need to live in somebody's pocket? Does it need to go and do a certain task that you've never seen before? So I would say, like, first and foremost, before you think about production, make sure you understand your customer and you actually start working with them and understanding what they need. And getting to this idea of a minimal valuable product, right? Minimum valuable business, where you have something that customers really want, they're willing to pay for it, and ultimately you hone in on that minimum set of features that you can deliver, and not spend 10 years of your life actually getting to this actual product. The second question is, how many of those customers are actually out there? So I'm not going to go through the framework on the right, but ultimately just understanding, yes, you might have one customer, but that means you just need to make one product. But for example, the construction industry, construction's happening all over the world, $1 trillion industry, and there's opportunities over and over again. If you make something that somebody loves when they're constructing a building, there's a great potential for somebody else in the next building over that's being built to want that as well. So again, take a screenshot, look up what the thing on the right is, and I'll help start understanding your potential market that you're entering into. The next big question around your business is, can you make this thing for less money than somebody's willing to pay you for it? So really understanding what your overall lifetime value of the customer might be, what your underlying COGS, and if you can make something for $99 but only get paid $100 for it, it might be very difficult, or will be very difficult for you to scale that business unless there's some broader software or broader service that you're entering into that business model. So there's many ways to address the thing on the right. Again, take a screenshot, Google what those terms mean. But the key is to start understanding the dynamics of your business before you start committing to production. And then the next thing is, when you start thinking about production, do you actually have enough money to do it? So actually making something costs a lot of money and a lot of time, and you have to think about all of the salaries and material costs, certification and tooling, office space, insurance, legal cost. And it's not that this is impossible, it's all very doable. It's just a matter of understanding all of the things that might come into play as you start going towards mass production. And I think the biggest thing, especially if you're doing this for the first time, is that do your economics, does your business model or your financial plan have enough wiggle room in it to make sure that you can mess up? So when Tesla's working on their Model 3 or Model X, they're in production hell, right? Like they were going through and actually building this thing incredibly quickly, and they could afford to keep messing up and figure it out as they go. That being said, if you're a startup or you're a small company, you might not be able to afford all those things. So making sure that all of this business that you're building out gives you actually time to mess up, time to learn, and time to figure it out, because it's not all going to happen the first time. And then you also have to think about marketing, sales, distribution, actually running a business. Despite what we want to believe, if you build a great product, it doesn't mean people know it exists or know that they know how to get it or even know how to buy it. So making sure you have those built in. And then everybody, especially in the Sigfox network, and basically all of the companies that we invest in are also software companies. So you need to be able to build this while actually building world-class software that works perfectly with this set of products. So hopefully that kind of sets the stage for a lot of big questions you need to ask around a business before you actually go into production. And some of the things out of all of these questions you need to start building is building out a set of useful documents or useful spreadsheets that ultimately start letting you understand the complexity of your business. So building out a financial model for the next couple of years based on when you need to make investments, when you need to pay people, when you need to actually get things done, bill of materials of the thing you're making, understanding of the unit economics. So that was the LTV, CAC, and COGS that we talked about before. And then ultimately a set of customer and product requirements that ultimately start serving where your priorities are and how you're working on it. So these are kind of a key set of documents. I think one of the most important things is to make sure that they are parametric and flexible, because your plans will change, your costs will change, your overall understanding will change. That will then kind of feed to how you shift some of these documents around. So that being said, now that you have kind of a plan in place, you have kind of a basic understanding of what you're doing. And again, this isn't like a one single loop. Often when I approach this is like, I go and try to create that plan as quickly as possible. I try to actually go make the first draft and then iterate and loop around this loop as many times as possible. So the next kind of chunk of this is actually, once you have a plan, you want to start executing, actually designing for a set of conditions. So DF actually stands for design for, and then X is all of the things that you actually have to design for when you're thinking about product and production. So designing for manufacturing, assembly, testing, reliability, designing for your customer. And there's actually a much longer list than this, but ultimately getting into the point where you're actually starting to take all these great ideas you have in your plan, what you need to deliver to your customer, and then putting them into real world scenarios of saying, how do I get this to market? How do I deliver something that's both viable and desirable to the market? And in like the simplest actually say is, how do you actually make the thing, right? So if you look inside of a product, it's got tens of parts, it's got dozens of parts, and each of these have different manufacturing processes, different ways of coming to life, different materials, different functional requirements. So a couple of things just to kind of kick this off is, first is design for manufacturing. And really kind of within this, there's certain processes. So really thinking about all the processes that actually are used to make different metallic processes or different metallic processes, plastics, injection molding, overall kind of different forming, stamping, CNC. Really, the list goes on and on. There's thousands of ways to actually make the parts and pieces in your products. And the big thing here is that you don't necessarily have to choose a production process and then change your product, or you don't design your product and then there's going to be a production process for it. This is part of the iteration, understanding the constraints of these processes, the different costs and different ways to market, to ultimately get to how does that product come together. The one that's most common, kind of especially in the world of connected devices and consumer electronics, is injection molding. So this is just where you're able to take a set of plastic feed, heat it up to a really high temperature, and then put it into a mold that ultimately comes out as the kind of the plastic parts and pieces that we see in all of our products today. So Legos, enclosures for IoT devices. Really, kind of this is probably the most common, one of the most common production methods that you'll be dealing with. So I think this is one, if you want to take a first step into understanding overall production process, this is the easiest first one. The next big thing that's very important is actually material selection. So are you making something out of metal, plastic, rubber, carbon fiber? Are you doing composites? Are you doing soft goods? And really understanding what your product is made of. And that speaks back to the requirements or the things that you actually need your product to do. And one of the unsung things within manufacturing is actually how you tolerance. So tolerance is actually saying how fine-tuned you need your part to be made. And it's actually one of the biggest engineering factors on cost, reliability, and performance. So if you need something that's within a few millimeters of each other, or a few hundredths of millimeters, or down to the few microns, and actually being able to spec those things out, it will be the difference between a huge amount of cost. So you have something that's very fine-tuned. It's going to actually increase your cost by a significant amount, especially if you're machining something. With plastics, if you have higher nominal dimensions, is actually going to lower your cost a whole bunch as well. So really kind of understanding how precise you need your parts is a massive consideration. And it's also a big thing to consider, especially when you think about the overall performance of your product, because it can be the difference between, this is a shaft going into a hole, and it's the difference between actually having clearance and no support and being wiggling around, to having the right amount of slip, to actually being able to not move. So actually having these things be built into how you're thinking about the product coming together, and ultimately kind of starts feeding back into your cost structure as well. And then that's kind of a bit more mechanical. There's also a lot around how you're thinking about shifting a lot of your PCB design or your electronics design. And right now, when you're building prototypes, it's a lot of hand soldering. It's a lot of grabbing things off the shelf, maybe ordering something online from DigiKey or wherever you might get it from. And you kind of hand solder it together, it works. But shifting to when you start going to mass production, actually designing for pick and place machines, designing for real base components, not for either through hole or large SMTs. So actually starting to shift how you're designing, how you're choosing different components based on higher throughput processes and more production methods. Once you kind of start building out those are the basic building blocks, actually the things that you need. Actually thinking about how do you actually put it all together. And this is where a lot of people don't actually think about what order do you put the parts together, how are they held together, who's putting them together, and that can be the difference between your product costing more than it needs to, or breaking down, or actually needing to rework the parts completely. So the first thing in this is actually more of an empathy exercise. So if you're thinking about your product, actually sitting down and saying, how might somebody on the other side of the world actually put this together the most efficient way possible? And that's thinking about not just oh yeah, do they have all the right parts? Does it go down the assembly line? It's actually thinking about the ergonomics of, can they find the right pieces? Is it easy to locate? Is it easy to actually put together and fit together? Because ultimately, that's what's going to happen is you're going to set a set of instructions. You're going to work with a team in the manufacturing line to actually say, how do I put my product together, not in 1 hour or 1 day, but actually do it in a few minutes. And that's the difference between a huge amount of cost or your product even existing. And even if you're kind of ordering all the parts and putting together in your house, it's also massively important that you are able to do something in the shortest amount of time, the most efficient amount of time as possible, because your time is incredibly effective. Even if you're planning on kind of gathering your family and doing a production run, designing for ease of use, untrained professionals to actually put these things together. And that's things like this, where if you have really small components, they're slippery, they're sharp, they're flexible, it's going to make it really difficult on your assembly. similar to actually designing the parts so that they can be easily assembled together. They have the right fits. They don't jam as they're going into different parts. Actually thinking about symmetry. So if I have a circular product and it looks the same on every side, how do I make it so that when somebody looks at this, they don't actually mess it up? So if you have something that's just basic, like asymmetrical, actually putting key features or putting some key elements in it so that when parts actually come together, they're always aligned, they're always going in the same place. And then yeah, so there's this list goes on. And I think the key here is that it's not necessarily about learning all of these things and kind of having these before you even start, but it's actually going in and prototyping these things, pretending like you're on the manufacturing line, seeing where things break, and then making design changes in order to make these things more efficient, not just for you, but for your future production. And then really empathizing how people are handling these things, how are they coming together, and ultimately, how do you make that most efficient as possible? And I think the key here too is continue to prototype. 3D print, you don't have to actually do injection molding. You don't have to do a final PCB run to actually test these things out. So as you're doing your prototypes and actually building these things out, actually don't just think about doing things functionally to work, but actually thinking about your assembly and how they start coming together. So this is an example of a 3D printed part that has some snaps in it. It's thinking about alignment. It's all in a very specific way that might speak to, in the future, how they actually put the assembly together. And then another thing that people don't often start to consider is actually designing for testing. So when you're going to production, in line, you're often doing testing of your electronics and your software before they go into the final product. So building an inline test jig. So as the kind of PCB is moving through the line, they'll take a jig, put some pressure on it. It'll electrify certain parts of the circuits. It'll run some software to actually validate and test the key elements of your product. And if you're not testing in line, you often have really poor yields, really bad products, and really bad customer experience. So these often can be very complex, take a lot of time, and often said, like, these are the products for the products. You almost have to spend just as much time in your building all the testing and jigs and all the things to make these things happen than it is to actually design the product itself. And then you start seeing hints of this when you maybe open up somebody else's product in PCB. You start seeing these little gold plates, that these are actually test pins. These are ways that you can actually test in line and run these products automated testing without actually getting out the testing equipment yourself. Keep going through this. This list goes on. Design for certification, but actually understand how you need to certify. So especially if you're doing anything with connectivity, you're going to be needing some sort of certification, whether it's for the CE, FCC, UL. If you're doing anything medical or food related, you're doing FDA. And there's, for most industries, they have critical either certification or ratings that you need to hit. So this goes back into your documentation around your product requirements document, but this is actually critical in your material selection, your process selection, and ultimately how your product comes to life. And most importantly is designing for your customers. So out of all of these things, you're making decisions that either shift cost around, shift how it's made, how it's used, and you can't forget about actually designing for the usability and functionality that your customers really need. So this comes to life in if you're making a consumer product, you're making an overall product, actually thinking about the industrial design, actually thinking about how it's used, how it looks, how it's made, and actually making sure the customer stays at the center of every single decision that you make, to make sure that it doesn't end up with something that nobody wants. And it's incredibly important to just keep making prototypes and giving them to your customers. So as you start kind of making changes based on manufacturing, assembly, where it needs to go as a product, where you need to think about your cost, continue to make prototypes, get feedback from your customers to see if that's within the realm of what they really want, or if you're really still serving that fundamental need we talked about before. And like, again, this is a lot, right? This is a ton of stuff. If you haven't done this before, it's okay, right? There's ways to get about this. And again, there's a couple ways Oftentimes people think that it's engineering flowchart. So if I need a certain type of process or whatever, there's an answer for it somewhere on the internet. Oftentimes there's not, and just don't ever think that you can navigate these decisions by filling in a overall form and somebody's going to give you a magic answer. The first thing is just taking some first steps into understanding these different processes and different approaches. One of my favorite entry books is Making It, and you can find this on Amazon or wherever you buy books online, but probably the best entry point in understanding a lot of these processes. And then the other big thing is there's a ton of experts that have done this for their entire career, or are situated next to these machines, or know these things. And there are lots of services that will offer you kind of big hundreds of thousands of dollars to actually work with them. There's actually a lot of people that are willing to jump on the phone with you for an hour, do a design review, unload a ton of knowledge, and you kind of send them your CAD, send them your PCB, and they're able to in maybe just a couple hours actually give you a lot of things to do and work on that you don't need to spend a ton of time and money for. So going on Upwork, even just looking in design engineer, manufacturing engineer, and jumping on the phone with a couple of these people to see unlock the next stage of your design. And then the other big thing is always prototype. So you're not doing this in a bubble. You're not sitting only on your computer. You should be making 3D prints of your prototype. You should be kind of putting it together, putting it in front of customers, iterating this over and over again. And as you start learning things, as you start kind of figuring things out, continue to make prototypes, continue to iterate, you eventually get to something that is manufacturable, customers love, and functionally does everything that you want it to. And a lot of times you'll end up learning something that unlocks a whole new function of your design, or a whole new opportunity that you didn't know about before. So this is, I've been showing kind of pictures of a group called Bartesian. So it's a company that's on market now that makes, essentially it's a Keurig for cocktails. So you put in a little pod and it's able to make you a custom cocktail. And so they went through this process, and you can see kind of the approach that they had. So by now, done all this iterating, you've started to figure out how, from an engineering standpoint, this comes together. Functionally, it's working. You're kind of just getting out of these EVT stages, or actually building out these engineering validation tests and entering into understanding how the design comes together. And this is really where, as you start having kind of your first EVT, is where you really need to engage with your production partners, or you're actually start searching for people that can help you build this, because nobody's going to be able to do this all themselves, especially if you're doing it the first time. So you have to think about who's going to be helping you make this. And when we're thinking about production or manufacturing, there's a few different ways to go. Some people approach it, well, they'll self-source. They'll actually go find every part themselves, bring it in-house, assemble it themselves. There's a lot of middlemen out there, so a lot of consultants and support networks and overall services that help you find and deal with your whole supply chain and production. And then there's complete outsourcing, where you can just send some CAD file and it'll come back. And really, we have every team, teams are constantly kind of working through this and figuring this out. And we often push teams to bias towards doing it yourself. One, especially if you're going through this first time and you need to fundamentally understand how your products come together, having a little bit higher control. It's a bit more work, but if changes happen, you are able to actually interject, work a little bit faster, and not have to deal with unnecessary costs that come with uncertainty as you start outsourcing things. So we tend to have teams, especially when they're doing the first time, it takes a little bit longer, a little bit more work, but ultimately lets you own your process a little bit more. The other big question that you'll have to ask is kind of where in the world you want to make this. So even though HAX is in Shenzhen, doesn't mean that every one of our teams is making in China. Actually the first rule of HAX when you come to Shenzhen is that you don't have to make in China. It's just a great place to do prototyping and understanding your supply chain and understanding potential for scaling your business. We actually have a lot of teams that are making things in Brooklyn, or making things in Japan, or making things back in Europe. And maybe they're having sourcing components or sub-assemblies in China. And really it's understanding where in the world is able to do the best thing for you. And I think there are some things that China just wins every single time. They're just one of the best mold makers, injection molding, overall PCB scaling and development, the supply chain. Just really, there are some things that China is going to be the best at for a while, but also a lot of things that can be done in different parts of the world. And it's really around understanding how you want to manage your supply chain and how you want to manage it coming together. And really, no matter what, wherever you're going to be producing, however it's going to be done, we tell, like after my first rule of doesn't have to be in China. The second rule is you always go and visit your potential partners. You can't just rely on Alibaba or kind of random sourcing websites. If you find a good potential partner, it's always best to get on a plane and go meet them, see what they're doing. And with that, bring your prototype. Actually, bring what you're doing as a great way to collaborate and understand these potential manufacturers, potential assembly houses, potential supply chain, so that they can actually bring their expertise and look at your product and give some feedback on it and all that. That being said, do protect yourself. So like if you go to different parts of the world or you're showing off things, make sure that you either have NDA in place and then having kind of your patents in place. That being said, protect yourself, but don't let it prevent you from going and learning and working with potential partners and potentially going and finding great business partners that want to work with you around the world. And then when you're out there, you kind of make sure, don't just go and choose one partner. The goal is to actually go and find 5, 6 potential partners. Go bring a checklist where you're actually going and comparing them on the same set of metrics. When you go to a factory, evaluate some of the qualitative metrics, actually seeing how clean it is, how well do they treat their employees, what is their overall governance structure for dealing with changes, even just kind of understanding who you're working with and how they're building a relationship with you. It's really critical to not just have them tick engineering boxes, but also being the potential for a great business partner as well. And one of the biggest things, if you're going out in the world looking for partners that have maybe built parts or pieces or processes that it's similar to what you're looking for. So making sure that they've worked with certain types of injection molding or certain types of electronics or sensors is critical for them to be able to go and do it over and over again. And oftentimes manufacturers will very easily tell you, yes, right, we can do it. That's still a maybe whether they can do it. Do your due diligence, dig a little deeper, understand how they're going to get the thing done for you. And if they tell you maybe or they tell you no, it's most likely a no. So being very, very clear on what you need from a partner and being able to have that business relationship. And the biggest thing that one of the mistakes that people often make is they go to a factory or come to Asia, they go different parts of the world, expecting that everybody wants to make their thing and it's about finding the right vendor that's going to do the job. But in reality, you're there to build a business relationship. You're going to be working with this person or this group for years or months or years, and ultimately getting to a point where you can understand, going to be able to actually have dinner with the boss, shake hands, understand who is who in the factory. So when things maybe are difficult or don't go right, or you maybe struggling to find cash, you actually have a good relationship with these people to not just kind of have it be a transactional relationship, but actually a business relationship. So go in with that mindset. So once you have kind of the potential partners laid out, you send out for some quotes for feedback. This is where your bill of materials comes in handy, where you're actually able to spec out things in detail, be able to give you very specific feedback. Sometimes you're going to be choosing a production partner that's not always the cheapest, but they have higher quality. They have other things that are of high value that aren't always going to show up in the lowest cost items. And really the mindset to hold on to is that you're selecting a partner, not just a vendor, not just somebody who's going to do this for you. So keeping that partnership in mind. And this is where really these critical documents we were talking about before are going to be really important in making decisions, and as well as kind of being able to be flexible. So if a manufacturer tells you a new set of information, you can actually update the different information in your models and actually see that show up in the rest of your business plan. So let's say you have a partner, you've kind of heading towards production. You'll then head into this next phase around PVT. It's production validation testing, where you're going and making first parts that are coming with real production, with real assembly processes that you ultimately want to do mass production. So this is kind of a test run, kind of making 10 or 100 of something to see if everything that you've laid out, often built with your partner, is actually coming together as you thought it would. And not just parts, but also kind of full assembled PCBs. And when you start getting these together, the first thing you do is test them, right? So actually testing each part, testing the variability, seeing if the tolerances are what you need them to do, if the functional elements are still happening, or still what you need them to. So you're measuring for consistency. You're measuring and actually testing your assembly processes. Are they kind of fitting and working as you want them to? And then also starting to test for some other things. So putting them into chambers that kind of shift heat, temperature, and humidity up and down to see if your product works in all these different environments. Doing drop testing to make sure it doesn't crack or explode if you drop it, and doing other kind of tests around electric discharge, and depending on what your requirements are, actually testing to see if this actually does what you need it to do. So one team that was here at HAX that went through this recently, it was a team called View. So it's a set of smart glasses. It's able to it basically has a bone conducting stereo in the earpiece, or kind of going over your ear, as well as some interaction modes for your device on the headset itself. And they made their first production run. They had some things they had to work out with their materials. But what they did in order to actually test to see if the materials was working, actually built these test jigs to actually flex the eyeglasses over and over again. So they're able to do 10,000 flexes to make sure that these things are going to work in the field over years of being worn on somebody's face. And the other thing that you can do is, so yeah, you can put it on a machine and flex it, but actually just give it to people to use. So this is where you can give these early products, actually test to see if your software is working, if it's actually everything that it's meant to be, and kind of identify bugs before you do more and more of them. At this stage too, it's also very critical to design and think about your packaging. How does it actually get it put into a box and start to head out to the real world? Because you can't just send a blank box or an open box out to the world. So actually, how is this protected and move out to the customer? And amongst all this, you'll find issues. You'll find basically you're guaranteed to find something wrong, and this is kind of the piece of paper that you'll use over and over again, an engineering change order. So if you're changing the size of a part or overall kind of your jigs, or if you need to change some of the elements that are happening inside of your assembly process, actually being able to fill out this. And this is where your documentation and how you communicate with your partner, and doing that incredibly well, makes these processes much easier. So being able to actually make changes to these defined documentations and having them be flexible, or at least understandable and clear, makes all the difference when you need to then go and make another run and do this, maybe go from 100 units to 200 and start kind of scaling and ramping production as you start learning and refining your process more and more. So you've gone through these early tests, these validation tests, you're seeing the production come together, you've made a few hundred of these things. It's time to press go. It's time to actually go and let's do a big run of 1,000 or 10,000 or whatever it might be. And there's some key questions around a consistently running line if you're doing batch production, depending on what you need to do, which you'll hit these questions when you get to the right point. But then ultimately, probably the most important thing is going to be around how you manage your cash. So what's your minimum order quantities? How does that shift with your variable costs? Like you might have to actually order 10,000 really expensive parts all at once, and you have to make sure you actually have money in the bank to pay for those things. What are your payment terms, either with suppliers or with your customers, to make sure they actually have money coming in and out? Making sure you understand your time to delivery. So sometimes if you're making something in China, it might take 45 days to actually get to the United States, or 30 days to get to to Europe. And there's always unexpected delays, whether it's holidays from around the world you didn't know, or there's a shortage of a material, so therefore you can't get it anymore. It's really kind of making sure that you have the money to be able to actually deal with all of these inconsistencies or delays. As you start building up, huge part of your process is going to be quality control to make sure that you're not wasting a lot of money on parts that break or parts that are meeting your quality standards. So actually building quality control methods throughout your both processes, items come in the door, but also going out the door and going out to customers. Knowing where these things live, so where are they being stored, who's storing them, how are they protected, what environments are they in, how are they moving to you and then ultimately your customer. How are they moving? So are they by boat, which is cheap and slow, by airplane, which is fast and really expensive? Is it moving over land if it's going from China to Europe? Or is it moving by truck from a port to a distribution center to ultimately your end customer? So understanding how things are moving around the world. And then most importantly, how is this getting to your customer? Whether it's a business customer that you're going to handle deliver this when you install it, or if you're shipping through Amazon, actually understanding how this thing gets from its first kind of parts and pieces in a factory all the way to your customer. And then that's it, right? And if after, I guess, 30 minutes of talking, you get to this repeatable cycle of mass production. And again, you've done all this amazing work, all this hard work, but it's all while you're building and testing your software, all while you're building a customer pipeline, marketing and branding, and then also building a team that can continuously do this and not just do it one time. So really, this is the things that you have to build alongside building your product. And the really exciting thing about HAX and kind of being a part of the ecosystem is being able to see all of these startups go through a lot of challenges, but at the same time go and build amazing products for their customers and build up really fantastic businesses all over the world and be able to kind of create new value all over the world. So I guess for everybody online that's excited to give that a shot and willing to go through the gauntlet of actually building those things out. That's kind of the rapid fire intro of getting from prototype to production. So with that, happy to answer questions. If you guys have any projects that are exciting and interesting to potentially want investment from HAX, please go to our website. There's an application button, and we'll happy to jump on the phone and talk about your project and the potential for it to become an investment of HAX. So with that, I'll pass it back to the team and then maybe answer questions for the last few minutes we have here.
Thanks so much, Garrett, for this great talk. Very, very interesting. I'm sure everyone was very interested. And we have already had some questions. So I'll start with the first one. What is the minimum ratio you advise between cost and revenues to be convincing for investors and to set up a viable business model?
Yep. So there's, I would say, not a specific ratio, especially with hardware. It very much depends on your business model. So what is your customer willing to pay? How is it structured? So you could be a B2B business or kind of a business focused on and business customers, and you could actually be signing $1 million contracts, and your cost could be negligible, or it could be nothing, but it takes a lot of time and effort to get to that business. Or you could be a IoT product that costs maybe $1, but you can only charge it for $1.50, but then you have a $10 subscription fee on your software. So actually having, it's I guess a more complex conversation based on the established business model. That being said, having gross margins that are on the order of, I don't know, 75, 80%, is helpful in order to get through production, distribution, and having the margins to acquire customers as well as having a profit. So it all depends, but having those gross margins is a good start.
Thanks. Another question from your slides. What is the name of the author that on the book for the beginners that you presented in the beginning?
Yes. Let's see.
Otherwise, I don't know if the author was written on the slide, but we'll share the slide.
It was written on the slide. It's Chris Lefteri, Lefteri.
Thank you. So just for your information, for everybody in this webinar, we'll share the slides afterwards, and you'll also have the session that is recorded, and then you'll find it on YouTube. So you can have access to the slides afterwards if you miss one specific detail on one specific slide. Another question: what are the most important criteria I should consider to choose my manufacturing partner, according to you?
Yes, the most important criteria. So I would say one of the most important criteria is, has that manufacturing partner made something somewhat similar to what you've done in the past? If you're making a robot and you go to an iPhone manufacturer, that's important. So making sure that they have the capabilities and the processes that are most aligned with your potential production. I would say the next thing is having a communication and governance process that is supportive of new products. So there are many factories that are able to do high volume, but they primarily work with large companies. So one thing when you go to a manufacturer is ask if they have an MPI or new product introduction program, or a startup program, or some way that they've demonstrated they've worked with a small company to begin with. That's very important, because then they have the capability to actually work with a new company. And then I would think just overall evaluating their quality control, cost, and then kind of reflective of the things that they've actually made in the past.
Okay, yes, very, very clear. We have a question from someone that is still with us. Not sure if the question is for you or for Sigfox. Is there any college or university challenge based? So maybe I'll try to give you the mic to Zamani Sitro. I see that he's still with us. If you can precise the question, is it a question for the HAX program or for Sigfox? Or maybe we can also provide an answer to one of us. Zamani, can you hear us?
Yes, I can hear.
Yeah, if you can precise.
You can hear me?
Yes, we can all hear you. If you can precise your question about, is there any college or university challenge based? Is it a question for HAX or for Sigfox, or for both maybe?
Yeah, it's for Sigfox. Are they providing maybe prototypes or components for universities or colleges challenges, so that we can maybe build with our students some of the things for testing purposes and also for learning purposes as a contribution maybe to colleges? Yes, that's why I asked this question.
Okay, thank you for your question. So I'll try to answer the best way I can. So we have several programs to support any either company, startups launching project with Sigfox. And we also have a program dedicated to students. So we launched a student challenge online in partnership with Hacksters.io a couple of months before. So we rewarded the best project that send content on Hacksters. Also, we partner worldwide with several universities to provide hardware. So if you want to, maybe I can introduce you to the person in the team in charge of the partnership. If you want to set up something with your university and to provide you material and maybe workshops on site. So another question. What is the average time and delay and cash required from a prototype working with a customer ready to pay enough to a mass production?
So it definitely depends on your product. So maybe for a simple IoT project, I would give at least 6 months, and that's often generous to make sure that it's fully working and where you want it to be. And then cash all depends on the overall complexity of your project. So you have to make sure you account for the variable costs that are in your actual cost of goods sold, but then tooling for plastics, which is several thousand dollars in several weeks. And it all really depends on what's in your project and how it's being made. But I would say the minimum is 6 months. I would plan for 12 to 18 months, depending on the complexity of your project.
Okay, maybe one last question before ending up the session. So I've got 100 units to order for clients, and is it a good strategy to order more to have available units in stock and to be more reactive in the delivery from clients?
I always order more, yes. So especially you often get the benefit of, if you need to order exactly 100 for your customers, you often can benefit from adding more to your order for lower cost. So oftentimes, if you either can order higher quantities, your supplier will give you better cost, or overall timing, you're able to actually get those in hand. Just a matter of whether you actually have the cash to pay for them. But I always order more. One, because you potentially can sell more. But the other part is that if you have maybe your production run isn't very good and it breaks, maybe 10 or 20 of those 100 or of this 100 break, you have parts and pieces ready to go to replace them. So I always order extra.
Okay, and which percentage would you advise for 100 quantity, for instance?
I'm sorry, can you say it one more time?
Which ratio, how many more would you advise for 100 quantity, for instance?
I would order, at least for 100, I would order another 25. But it all depends on how much money you have, where you are in terms of if you want to change the design from your first 100 to your next 1,000. And it all depends on how much you want to invest in that current generation of your product. So I tend to order a few more, but if you're ordering 1,000, it doesn't mean that you order 250 more. It's maybe a different scale.
Okay, thank you. Okay, so maybe very last question that just being for mass production, does the licensing, is it required always?
Licensing? Let's see. So short answer is no. So licensing, maybe I don't fully understand it. Like I would say, you can either fully own your product and your process, and then there's opportunities to maybe license out your technology or whatever it is. But I would say licensing is not required, and that might be, I don't know if that's a Sigfox question or not too. So
okay. Thanks so much again, Garrett. It was a great talk. So everybody, we'll send you the slide afterwards. It's okay for you, Garrett, that we can share the slide with participants. Beautiful. And we'll upload the video on YouTube, so it will be available. Feel free to share it to everybody that would be interested. Thanks again, and have a good end of the day in Shenzhen. And see you next time.
Yeah, thanks everybody.
Bye-bye.